Hi everyone, my name is Emma and welcome back to Science with Emma. I am currently doing my master's degree in astronomy, space science and astrophysics, and in this series I want to teach you guys about science in a fun and accessible way. So stick around because today we are asking the question, what are stars made of? You might have heard that you're made of star stuff, but what does that actually mean, and is it even true? Well, stars are mostly hydrogen. It's the simplest atom in the universe, just one electron and one proton, and most of that was created during the Big Bang. So stars can be anywhere between about 70 to 90% hydrogen, and in the case of our sun, it is 74% hydrogen by mass. In the star's core, hydrogen undergoes a process called fusion, where smaller atoms combine to make bigger ones. And it's by this process that we get heavier atoms like carbon and helium. Therefore, the second most abundant element in a star is generally helium, and it makes up about 25% of our sun's mass. Helium is an atom most commonly made of 2 protons, 2 neutrons, and 2 electrons. And in a star, it is created by something known as a proton-proton chain, whereby 6 hydrogen atoms combine to make 1 new helium atom, 2 hydrogen atoms, 2 protons, 2 neutrinos, and some gamma rays. So if you were really quick on your math there, you will notice that hydrogen and helium only make up 99% of the mass of our sun, and the rest is made up of elements heavier than that, known as metals. Now, astronomers call anything that isn't hydrogen and helium a metal, which is kind of confusing, but we're just gonna roll with it. These different metals are found in tiny trace amounts, 0.1% in our sun. However, they are pretty important. If stars are mostly hydrogen and helium, where does everything else come from? Well, stars gradually burn through their hydrogen fuel during their lifetime, and when they begin to run low, they start burning helium in their core, turning it into carbon. This process is known as a triple alpha process, and 3 helium atoms combine to make a carbon atom, as well as releasing some gamma rays. In these dying stars, we also have a number of other heavy elements produced. In fact, they can produce elements as heavy as iron. The most massive stars, ones more than 8 times bigger than our sun, are able to create even heavier elements than this through a supernova, which is a stellar explosion. In these types of explosions, the star collapses in on itself before exploding outwards. They're big, dramatic events that produce huge amounts of energy and throw all of the star's material far out into the universe. Every single natural atom we see in our universe comes from either the Big Bang at the very beginning of the universe or from a star. So yes, we are all made of star stuff with a little sprinkling of particles left over from the Big Bang, as is pretty much everything else in the universe. However, there are a handful of elements that we can only produce synthetically here on Earth, though they are generally very unstable, don't live long, and are pretty irrelevant for today's video, so we're gonna skip over them. The most common elements found in regular main sequence stars like our sun, aside from hydrogen and helium of course, are, and I'm gonna have to read this off my screen because I cannot memorize this many words: oxygen, carbon, iron, neon, nitrogen, silicon, magnesium, and sulfur, though these are generally only found in very trace amounts. And in total they make up between 1 and 2% of our sun's mass. So to conclude, stars are almost completely hydrogen and helium, though they do have small trace amounts of other elements which are known as metals. A star's composition will change throughout its lifetime as it burns through its hydrogen and subsequently its helium, so it will be born with a lot more hydrogen than it ends up with when it's dying. Lower mass stars can produce elements as heavy as iron, while higher mass stars can produce even heavier elements during their explosive deaths known as supernova. The material produced in a supernova is quickly dispersed by the explosion, and it goes into making more stars, planets, people, and pretty much everything else in our universe. So thank you all for joining me today for this episode of Science with Emma. As always, I have left my sources in the description below, as well as where to find me on social media if you fancy giving me a follow. Shameless self-promo. Also, if you have any more suggestions for videos in this series, please leave them in the comments below. I'm always happy to take your suggestions. I want to teach you guys about what you want to know. And I will see you all soon. Bye!